So today we're going to do a quick video on async versus multi-threading. What is async and what is multi-threading? And I'm doing this video because I've been confused about this concept, and I read a lot of articles about it, and I've got some sense of it. Okay, and I'm going to share that sense with you all. Okay, and I want to make this whole concept easy and really bring it down from the abstraction to an abstraction level where you can understand it. So let's try to understand what is a normal situation. So I'm going to give you an analogy of a car. You've got a car and you've got to go from point A to, let's say, point B. Okay, and you have a car. Excuse my excellent drawing skills. I just wanted to explain the concept. So this is your car, and this is your path from point A to point B. Now you are traveling on this path, and let's say this distance is gonna take you about 30 minutes to cover, right, on a regular day. So we don't envisage any traffic or anything. We just simply say that it's gonna take 30 minutes for you to take. Now this is a normal situation. Now imagine that this particular car in a real life situation has to go through that same route. Now if the route is going to be busy, this process is going to take more time. So let's say it's going at a high traffic zone. So let's say your traffic is at peak now, okay, and you are trying to go to work and your traffic is really heavy. So what you're going to do, you're going to get stuck behind other cars. Okay, so there is one car, and then there is probably another bus, and another one. So you get the idea. So what happens is, your car, to reach the same destination, which is the same distance as previous to in the previous explanation, now it's going to take you 60 minutes. Okay, so the question really is, how do you solve this problem? How do you go faster so that you reach your destination quicker? So one way to go is, now here it doesn't matter that you're having a Maserati or you're having a Mercedes Benz or any fast car, because you are stuck and you are constrained by the road on which you're traveling. And this is what really happens on computers as well. You could have the best computers, but the way the processor is designed is the speed is constrained by the number of tasks that are running. Okay, so there are two ways to handle this. So the first way to handle this, let us talk about multi-threading, right? So what typically you can do is, you can say that instead of having one road from point A to point B, what I'm going to do is I'm going to create a parallel road. Okay, or probably I'm going to create a shortcut which is going to go from some other place, and it will reach the destination. Or I'm going to create probably a flyover, okay, at choke points, so that the traffic is not getting blocked there. Okay, so these are possible solutions. So the first solution that anybody would try in this scenario is to have multiple roads, and the second solution will be to create some kind of flyover, because the road, there'll be a limit to how much wide you can make the road, and you will also have alternate routes for going from point A to point B. Now this, if you look at it, is basically multi-threading. So here you have one thread going, another thread going, another thread going. Now this can also mean parallel processing in a computer. So today the computer comes with different cores. So what it means is that if your system is running faster and you have a RAM which is higher, so what you're essentially doing is, by increasing the RAM size, you're increasing the width of the road, and you're allowing, the cores. So there could be core number 1 of the computer, or there could be core number 2, or there could be core number 3, or you could be core number 4. So you're essentially using different routes to reach the same destination, thus you're reducing the traffic, and you might not even reach here in 30 minutes, or you might reach here in 20 minutes, who knows, right? But the whole idea is that in multi-threading you are using an approach to reduce the time to reach. Now async is a little more finessed, in the sense that async sort of envisages this program or this issue during the programming phase, and you write your code in such a way that your code does not impact the traffic as much as it should. Okay, so the overall resource, now in this particular example you'll have to create roads, you have to invest in flyovers, and this is going to take time. So this is a capital heavy, investment heavy process, which is multi-threading, right? But let's say you don't want to spend too much money in doing this job. Okay, you want to be more efficient, but you know that there are some blocks where you can utilize it. So one way I can manage this challenge is by saying that I am going to assign cars, let's say, odd and even numbers. So a car with an odd number will travel between 9 and 11. Okay, and a car with an even number will travel between, let's say, 11 and 12. Okay, or you tell people that this is the time allotted for you, you can only come onto the road at this particular time. So if you would have noticed, in some areas school buses start early, so they capture the early window, which is the 6 a.m. to 8 a.m. window. So you capture the 8 a.m. window, and then the office hours starts at 9 to 11, and then you start capturing that 9 to 11 to 12 window. And here you're managing the problem in such a way that when the road is empty, you are allowing the car to travel. Okay, and after you have gone, then you allow the next car to come on the same road at a different time. Okay, the road is the same, but you're going to use your intelligence to manage the traffic so that the load capacity or the utilization of your network is 100%. Now this may not be the real case scenario, because in real case scenario everybody has to go to work at 9, so there is a peak time. Okay, so when your computer is getting used, there will be a peak time, so this is difficult, but this is an advanced concept. The concept basically says that you are managing your programming code in such a way that the code is not waiting for one particular function to execute its process, and the code is, if the code requires 3 particular functions, it basically jumps this particular function and goes directly to the second function. Okay, and the second function might not be dependent on this, it may be dependent on something else. So you look at dependency, and then you basis that you decided, all right, I want to use this third function and I'm not going to use the second function, and I will come back to the second function, which is like probably accessing a database. Once the network traffic comes down, I'll use this. So async requires a deep level of understanding at a programming level, at an architecture level, at a level where you understand which calls are going to happen, how the network works, and how the program works. So this is more advanced in terms of execution. This is mostly raw power. So here you are simply increasing the capacity of the road, thereby you're sort of increasing the load factor. So you might have more capital expenditure here, but because you created more roads, automatically the traffic moves faster. So this was a very baseline explanation of how async and multi-threading are different and how do they work. I hope you sort of understood the concept. I just wanted to get a sense across to you all in terms of multi-threading versus async. And if you understood this concept, and if you have any further comments to it, please do not hesitate to add that to the video. Thanks very much and have a great day. Bye.